Hello, welcome to tutorial 4. We are nearing the halfway point, but we have a lot of ground to cover today, so let's get started. The first item I want to discuss is the data selector. Remember, we want to make a program counter. We either want to count from the current value of the program counter or from the jump value that is in the jump register. Herefore we use a data selector, and I made one in a simulation program called LogiSim, which inspired me for the project in the first way. It's so nice to draw a drawing of some logic gates and then it actually works. But with transistors I found a way to do this in reality, and it's much more fun. So I think you all know the basic setup from a data selector. You have a select button. If it's high, you get one set of data. If you get low, you get the other set of data. Quite easy. Here's a slide of how it looks like in Gerber, and I immediately switch on to the real thing, populated with transistors and resistors. You can design your own boards, that's fine. You can use mine, they are on the Google Drive. If you use mine, here's the bottom of the board. You need the order to make the right connections. I go back for a second to what we did last tutorial. We omitted a piece of the program counter just to make it work without jump. And we omitted a part, and we are going to build this tutorial. Remember also how it worked, that we use the clock on two ways. We use the clock and the inverted clock, and that gives us two rising edges per clock cycle. Here's the finalized picture. If you utilize the data select board, you can attach on one side the jump register, on the other side the temporary register, and by switching the select on or off, you can switch between those two values. Here I made a picture of the actual situation on the board. It is complicated, so let me talk you through it. I begin with the lowest one. Where the arrow ends, there's the output of the whole thing, of the whole program counter. That goes to the control electronics and the programming. I disconnected it now, and it lays a little bit lower than the arrow. Then from the top you see first a couple of boards. You don't see them completely, but this is the jump register and the select board. So that switches between the jump register and the temporary register. Below you find the input connection of the program counter. Then the arrow that goes to the left, the program counter itself, two boards, 8 bits available, 6 bits used. Then the other boards, 3 2-bit boards, and below that board you will find the hardwired 000001. Then the shorter arrow is the temporary register, which allows the adding up process to continue within one clock cycle. And the 8 wide ribbon cable is the program counter bus. It's no longer than that. It's a shame to call it a bus at all. Okay, here's the video again. I'll talk you through it. The setup is just like I explained in the photograph. When I touch the select button, the value in the jump register, which is 5 at the moment, goes to first the temporary register and then the final register, but it adds up 1. So next time I touch it, wait for it, it goes to 6 again. Now I'm going to change the value in the jump register to make it clearer, and then again the jump register plus the value 1 comes again into the system. I'm not shy of telling you that I love JLC PCB. Why? The first board I ordered was very exciting because I thought I made a lot of mistakes. And in truth, my mistakes is the only mistake you have to fear, because JLC PCB doesn't make mistakes at all. The first order cost me €5 delivered to my door for 5 boards. And when I got back to them, they had a coupon waiting. They do this very often. They're very professional. If you send in a correct Gerber file, you get a correct board. So I'm really pleased with JLC PCB. To get further ahead with the project, we need to discuss some peripherals. First of all, the clock. I use a Pico, which I programmed with help of ChatGPT to do the following: to have a clock, to have an inverse clock, to have a delay clock, and a delayed inverse clock. Delayed means that the rising edge is 10 milliseconds later than the original clock. I use this if I want to put something on the bus. I use the direct clock, the clock. If I want to read from the bus, I use the delay clock. So I'm sure that this 10 milliseconds which 10 milliseconds is eternal in electronics, so the value will be there. Here I give the pinout of the Pico I used, and the program will be in the Google Drive. If you want to be more purist, you can make your own electronic transistor based setup. You need an oscillator, and you need a number of NOT gates, and you can follow this schedule. A NOT gate will use some time, not much, but if you use 20 you will have enough delay. Then here you have the actual board. I put in there 9 NOT gates because I was worried that the voltage of the Pico 2, which is 3.3 volts, wouldn't be enough to steer the rest of the electronics. But the board is there, but I haven't attached it to anything, so it'll be okay, just the output of the Pico. Well, then I continue to the display output. I also asked ChatGPT to write me a program to read the value of 8 pins and convert it into a decimal value. I think I have a joke in there somewhere as well, but you need to see for yourself. The program is in Google Drive, and the pinout is here. Then I have some shots I used of the screen I used, which is a SSD 1306, I believe, and it's really too small, so next to it you see my future screen, which is a decent LCD screen. Next time we will continue with the program board, the ROM, and the way I program this computer. Thank you all for watching, for sharing. If anything is unclear, please let me know. I'd be happy to answer your questions, and see you next time.